Hi, this is John Linneball, and this is Barron's Chapter 6L, Circles. I'm with John Linneball Tutoring. Here's my address, here's my phone number, and here's my email. Don't worry, there'll be more information at the end of this video if you didn't catch that. For the best results, I suggest you use the Barron's SAT 30th or 29th edition, or even the 28th edition. This video covers pages 601 through 602 in the 30th edition of Barron's SAT, the Premium SAT Study Guide. The page numbers are the same in the 29th edition, and they're identical or close enough in the 28th and previous editions. You shouldn't use an edition older than Barron's new SAT from 2016 in any event, because they changed the test. That's why it was called the new SAT. Not everything in the book is in these questions. Do read the book, do get yourself a copy, go look at it. Some things that are in the actual chapters or sub-chapters in Chapter 6 aren't in the review questions at the end, so do read the book. The older editions of this book can be had cheaply, if not for free, from used booksellers, kids have already taken the test, and public libraries. A lot of public libraries, at least around here in the San Francisco Bay Area, sell old editions for seriously like a dime when they're trying to get rid of it, or you can borrow the current edition, of course, from the library. So if you do plan to use a library copy or buy a new edition, I suggest you start early. There's no worse feeling than needing a library book someone else has checked out, or trying to buy a review book that's already sold out. So give yourself some time. You're going to need the time for the review anyway. Question 1, page 601. What is the circumference of a circle whose area is pi cubed? Well, we know the area of a circle is always equal to pi r squared. That's why a equals pi r squared. Since a is equal to pi cubed equals pi r squared, that means r squared has to be equal to pi squared, so r is equal to pi. Since c is equal to 2 pi r, c is equal to 2 pi squared, so that's choice D. Question 2, page 601. What is the area of a circle whose circumference is pi squared? Well, again, we know c is equal to 2 pi r, so pi squared is equal to 2 pi r. We can divide both sides by pi, and then by 2, so then we get the radius r is equal to pi over 2. The area is equal to pi r squared, so a is equal to pi times pi over 2 squared, which is going to be pi cubed over 4, which is choice C. Question 3, page 601. What is the area of a circle that's inscribed in a square of area 2? Well, since the square has area 2, we know that each side has to be the square root of 2, because the square root of 2 squared is just going to be 2. That's why they call it squared, because you take the side length and multiply by itself, so that's why it's called square, because it gives you the area of a square. All right, since the side length is root 2, square root of 2, the radius is square root of 2 over 2. Why? Because a side is this length, and we can see the radius is going to be half of that side length. So this is square root of 2 over 2. Since a is equal to pi r squared, it's equal to pi square root of 2 over 2 squared, and that means the area is equal to pi times 2 over 4, because square root of 2 squared is 2, 2 squared is 4, which of course is just 1/2 pi, which is choice A. Question 4, page 601. A square of area 2 is inscribed in a circle. What is the area of the circle? Well, we know the side length of the square is root 2 from the previous problem, right? So then we know the diagonal is going to be root 2 times the square root of 2, because it's a square can be split into two 45, 45, 90 triangles, and the side ratios are going to be 1, 1, and the diagonal is root 2. So if the side length is square root of 2, this is square root of 2, square root of 2, then this is going to be square root of 2 times the square root of 2, which is just 2. So since the diagonal of the square is also a diameter of the circle, as we can see here, so then that means the radius is 1. It follows that the area is pi times 1 squared. 1 squared, of course, is just 1, so the area is pi. That's choice B. Question 5, page 601. What is the area of a circle whose radius is the diagonal of a square whose area is 4? Well, again, we know that the square's side length is 2, because 2 squared is 4. So the diagonal has to be 2 root 2, which is also the radius of the circle. So since we know the radius of the circle is 2 root 2, then the area is pi r squared, since r is equal to 2 root 2. That just becomes 8. The area is 8 pi. That's choice C. Question 6, page 601. What is the length of arc RS? Well, the arc length is proportional to the central angle, so RS over 2 pi r is equal to 144 over 360. Why? Because it's a 144 degree angle. The area of, or not the area, I'm sorry, the degree measure of an entire circle is 360 degrees. So RS over 20 pi, because we know that 2 pi r is going to be 20. Well, it's going to be 2 pi times 10, which is 20 pi. So RS over 20 pi is going to be equal to 2/5. That's what 144 over 360 reduces to. So RS is going to be 2/5 times 20 pi, which is 8 pi, which is choice B. Question 7. What is the area of the shaded sector? All right, we already know this is the same from the previous question, question 6, it's the same diagram. So we know that A is equal to pi r squared, so 10 squared is 100, so the area has to be 100 pi. So the area of the sector is going to be 144 over 360 times 100 pi. We already know that 144 over 360 is the same as 2/5, so 2/5 times 100 pi is 40 pi, which is choice D. Question 8. In the figure above, what is the value of x? Well, since two of the sides are radii of the circle, you know, the plural of radius is radii, so we know that this is a radius and this is a radius. So that means this side has to be equal to this side. So since it's an isosceles triangle, we know that angle x has to be equal to this angle here. So 72 is going to be the odd angle out, so to speak. How do we know that? Well, because if these were the same and this were the same, then they'd have to be 60 because 180 divided by 3. So we know it's not an equilateral triangle, but it's isosceles. So all we have to do is subtract 72 from 180 to figure out the sum of these two angles. That gives us 108. And then we're going to divide that by 2 because we know these are equal. So if you divide the 108 by 2, you're going to get the measure of angle x and whatever you want to call this angle y. I don't really care what you call it. So 108 over 2 is equal to 54. So that's the answer. Question 9, page 601. All right, if A is the area and C is the circumference of a circle, okay, remember circumference is the diameter times pi, or it's 2 pi r, whichever is easier for you. Well, here C is the circumference. So we know that C is equal to 2 pi r and A is equal to pi r squared. All right, so if we want to express the area in terms of C, let's see if we can, no pun intended, see, haha, get it? Okay, we can just solve for r in terms of C, so we end up with r is equal to C over 2 pi. We just divide both sides by 2 pi. So now that we have r is equal to C over 2 pi, we're just going to substitute C over 2 pi in for r. So instead of pi r squared, we're going to have C over 2 pi squared, so that's pi. I couldn't get it to make a nice superscript here, so I just put instead of C squared, C times C. So we have pi times C times C. Pi squared, also had trouble with that. So 4 pi times pi. All right, so we know this pi and this pi cancel out. So we have 4 pi, and then we have C times C. So then when I write it not quite as nicely, you get C squared over 4 pi, which is choice A. All right. Question 10, page 602. All right, so in the figure above, L is a line which is tangent to circle O at A. So we know O is the center of the circle. That's why they call it circle O. They name it after whatever point is the center. So we have OAB. All right. So what are we going to do here? Well, we know that L is tangent to this radius, and they touch at the point of tangency. That is where this just barely touches the edge of the circle. There's a radius that goes right here. We know from our reading, hopefully you've read this in the book or you know this from your geometry class, whenever you have a radius that meets with a tangent at the point of tangency, it forms a right angle. Since this is length 2, the radius is 2, and this is also 2, we have an isosceles right triangle. So if we have an isosceles right triangle, that means the legs are both 2. That means it's a 40, well, isosceles right triangle doesn't mean the legs are both 2, but since they're both 2 and it's a right triangle, it's an isosceles right triangle is what I'm trying to say. Anyway, since we know these are the same, that means these opposing angles have to be the same, that's opposite this side and this side. So since it's a right triangle and it's isosceles, it's 45, 45, 90. So then all we have to do is we can first find the measure of find the area of the triangle, which as we can see is really easy. It's just 1/2 base times height. See, this is the base, this is the height. Hey, for giggles, you could say this is the base, this is the height. Doesn't make any difference. So 1/2 base times height is 1/2 times 2 times 2 equals 2. So you're probably asking, John, we did that without even having to know anything. We just, do we have to know the triangle is 45, 45, 90? Well, yeah, for a couple of reasons. One, you wouldn't necessarily know that this is the base and this is the height, because the height has to be perpendicular to the base. So if this were not a right angle, we would have to figure out what the base was or what the height was, and we wouldn't necessarily. But a simpler reason than that is to find the shaded area, we have to subtract the area of the sector of the circle that's inside triangle ABO. And we can't do that without knowing the measure of angle O. So the radius of the circle is 2, so the area is 4 pi, pi r squared, so 4 times pi. But if we didn't know this was 45 degrees, the only answer you could give is cannot be determined from the information given. And that's not an answer choice. So what you can do here is we know it's 45 degrees, so therefore the area of the sector is going to be 45 over 360 times 4 pi, because that's the area of the whole circle. So whatever, 45 over 360 is just the proportion that's inside this sector here. So that becomes pi over 2, because 45 over 360 is, that's 1/8. Because 90 is 1/4, so you can just divide that in 2 to get 45, so that becomes 1/8. So 1/8 times 4 is, of course, just going to be 1/2, so this all works out to pi over 2, and the shaded region is 2, because that's the area of the triangle, minus pi over 2, which is the area of the sector, which is choice C. Question 11, page 602. The circumference of a circle is a pi units, and the area of the circle is b pi square units. If a equals b, what is the radius of the circle? Okay, so we know that the circumference is 2 pi r, which is going to be equal to a pi. Therefore, the a is equal to 2r, so r is equal to a over 2. And then the area is pi r squared, which is equal to b pi, so r squared is equal to b. So a is equal to b, so 2 pi is equal to r squared, and r is equal to 2. So that's how we do that. Okay, so that's that answer there. Question 12, page 602. A 9 by 12 rectangle is enclosed, not enclosed, should be, well, enclosed should be inscribed, because you want to know that these corners or vertices meet at the edge, exactly on the edge of the circle, even though it's not quite drawn accurately. Sorry, it's the best I could do. Anyway, it's a good idea to draw a little diagram. We can see the rectangle can be split into 2 right triangles, because rectangles always have 90-degree angles as their corners. So with a common hypotenuse, this is the hypotenuse of this triangle and of this triangle, that is a diameter of the circle. So since we know one side is 9, one side is 12, we can quickly just use the Pythagorean Theorem to find that 12 squared plus 9 squared is equal to the square root of 225, which is 15. Hopefully that'll be on a calculator section. If not, it's a good idea to memorize your squares up to 20, certainly at the very least up to 15, because you're going to end up with things like this, like 169. It's good if you look at it and go, oh, that's 13 squared. It's good if you look at 225 and go, oh, okay, that's 15 squared. If you can look at 400 and say, oh, that's 20 squared. But I digress. Anyway, then we just divide the diameter 15 by 2 to get a radius of 15 over 2, or 7.5. Either one is fine. It's a grid in. Either one of these would fit into the grid in thing. In my book, I put in 15 over 2. If you want to put in 7.5, I don't have a problem with that. Okay, having a little problem with talking, but anyway. Question 13, page 602. Since arc AB is 2/15 of the circumference, okay, so it says here in the figure below, the ratio of the length of arc AB, so it's this thingy here, is the circumference of the to the circumference of the circle, so that's all the way around the circle, is 2 to 15. What's the value of y? Well, okay, so y degrees has to be 2/15 of 360 because this central angle and this arc length are going to be directly proportional. So that means when this goes up by some proportion that's always the same. So, all right, so we can take 2/15 times 360, end up with 2 times 12 times 15 times 2 over 15. Boom. Those cancel out, so we end up with 2 times 12 times 2, which is just 48. Factoring is a great way to make the math easier, especially if the problem's in a non-calculator section. Notice that I did not even have to touch a calculator to do this. Question 14. If the area of the shaded region is k pi, what is the value of k? This is a grid-in question, so yeah, they want to factor the pi out, so they can just give you an easy number to factor in, and you don't have to play around with 3.14 or whatever. So anyway, the two non-shaded areas, so these thingies here, you can see they're vertical angles. Okay, the fact that they're inside a circle doesn't change anything. They're still vertical angles. Vertical angles are congruent, so that means if this is 40 degrees, this is also 40 degrees. So the combined angles of the non-shaded areas, you know, the white or whatever color this is, kind of beige, whatever, are 80 degrees. And the shaded areas have a combined angle measure of 360 minus 80. Remember, the whole circle is 360. We subtract 80, we get 260. No, actually we get 280. Okay, oops. Anyway, since r is equal to 6, the area of the circle is 36 pi. So the shaded area is 280 divided by 360, not 260 divided by 360. Sorry about the typo. So anyway, 280 over 360 times 36 pi. So we know that 7 times 40 is 280. 9 times 40 is 360. So k is equal to 7 over 9 times 36. Okay, so 1/9 of 36 is going to be 4, so it just becomes 7 times 4, which is equal to 28. Okay. Question 15, page 602. If line L is tangent to circle O at point P, if B is a point on line L such that PB equals 8 and OB equals 10, what's the radius of the circle? Well, you can draw a diagram. So since we know a tangent is perpendicular to the radius that meets it at the point of tangency, angle OPB is a right angle. Thus we can use the Pythagorean theorem, a squared plus b squared equals c squared, to learn that r is equal to OP is equal to 6. So we just see this is a right angle, this is 8, this is 10. Okay, so Pythagorean theorem, we know the hypotenuse, the square is going to be 100. This is 64, so it's just going to be 100 minus 64 is 36. Square root of 36 is equal to 6. Did you find this video useful? If you did, please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? Well, it's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time. Still have a little bit less than the 700 subscribers, so don't have the 1,000 subscribers I need either. If there's a copyright issue, please just contact me and I will help you. For the same reasons, you're not only welcome but encouraged to share links to this video, put it in playlists, etc. I'm always happy to read and respond to constructive criticism or suggestions for new videos. I reserve the right to delete comments from and block those who specialize in destructive criticism. You know, the people that we call trolls or trollers or whatever. Or people who just want to post things that are off topic, spammers, disturb people, people who just decide that whatever their pet issue is the most important thing in the world and belongs in my comment section. No, I will delete things if they're causing problems. You can contact me on my cell phone, 415-623-4251. My email is john@johnlinneball.com. My mail is 1859 Powell Street, number 109, San Francisco, California, 94133. And thank you so much for watching. And if you need even more contact information, Facebook. You can find me on facebook.com/Linneball Tutoring, just my last name with tutoring after it. Instagram, you can find me on Instagram.com, john.linneball.tutoring. My phone number at home is 415-986-7355 in my home office. email, you can email me at john@johnlinnebaugh.com, and you can go to my website, johnlinnebaugh.com. johnlinnebaughtutoring.com takes you to the same website, so knock yourself out, have some fun. All right, hope you found this educational. Have a good day.